Today we will study the combustion of fuel in the combustion chamber, the chemical reacting mixture. The fuel, we will try at first hydrogen, maybe then some other fuels. And at first we will try to do it in ANSYS CFX. You can choose between these two programs, CFX and Fluent. We'll try to do it in both programs, but at first it's more simple to do it in CFX. So I have opened the Workbench project. Все понял, ладно, разберемся. Let's continue in English. So let's open the project Fluid Flow CFX on the working table, and we'll try to build very simple geometry. Axisymmetric chamber, and in the center the fuel is exhausted from the nozzle, and the co-flowing flow is the air. So right click on geometry, select new design model geometry, in the 3xy plane, look at the face, so change to the view for xy axis. Then go to the sketching page, and we will choose very simple geometry, rectangle. It will be the rectangle for our chamber. But I think I have very big dimensions, meters, but I will not change them. I will change it later. So the height and the length of the chamber, we will make something about 1 meter. The length, maybe 2 meters, the length, and about 20 centimeters radius of our chamber. So dimensions, at first radius of chamber, V1. Now it's about 5 meters. I will change it to 0.3, oh, maybe 3. Yes, okay, 3 meters, 30 centimeters, 0.3 meters. and the length of the chamber we will make 2 meters. Okay, very small picture. But now it's more realistic than 50 meters, 15, or even so. In the right we will make 2 inlets, the inlet of air, and near the axis there will be the inlet of the fuel. To do it, we will open Modify page, select Split option, and split the left part of our inlet into 2 parts. And again, return to dimensions and set the radius of our fuel inlet. .05, for example. The 5/100ths of the meter, 5 centimeters. And that's all. The sketch is ready. Now return to the modeling. The isometric view. And make the revolve operation. So select revolve. We must select geometry. The geometry is our sketch, so we will select sketch 1 and click apply at the geometry option. Now the geometry is sketch 1. The axis. Of course, we will use the revolve operation around the x-axis. So click on not selected. Then select x-axis and again click here apply. We have done the whole revolve operation for 360 degrees. It's not very good for axisymmetric problems because we will get very big mesh. It's not good. The time of the solving of the simulation will be very great. It's not good. So for axisymmetric operation we should not use the whole revolve operation. Let's change at first the direction instead of normal, we use both symmetric operation direction. And the angle is recommended very small. We will take 5 degrees. It will be enough for our simulation. 5 degrees. Okay. And it's very important. I want you to pay special attention. We should change the merge topology. Instead of yes, we must use no merge topology. Why is it so? Because we split it, the left inlet part, into 2 parts. If we use yes, the geometry will merge both inlets and we will not get 2 inlets. We will have 1 part in our geometry. It's not good for our problem. We can later improve this situation, but it's better to do it now. So no, and then click generate. I think it's very good for our simple problem. The geometry is ready. Let's save the project. File, save project. I have a special folder for this. I call this folder ANSYS 2021, and I am using new folder which we'll call chamber, in short, chamber, and I will put the date 15/9, today's data. Chamber. It will be the first project, so I will call it 1 and save. Now the geometry is ready, and next we will build the fine mesh, not using the standard mesh operation, but using the best mesh program, mesh building program, which is called ICEM CFD. It is located in component systems. So let's put it on the table. And export geometry, our geometry. I will close the window geometry. It's ready. Export geometry to model of the ICEM CFD. Drag and drop operation. Geometry to model transfer. Now they are connected, and so the geometry from the main project is exported to the ICEM CFD model. Let's open the model. I hope that you have already studied my previous lessons. So the ICEM CFD program is common to you. In the tree, I open the geometry option and checkpoint. Now I have curves for our flow region and the points which located in the useful for us places. Now, as in the previous lesson, we must make the paths where we will set the boundary conditions later. So open the paths, click right button on the paths, create path, and now we will start to set our paths for boundary conditions in future. The first part we will call outlet. Sorry, at first I must check the surfaces also for showing the faces on which I will create paths. So the outlet part, you may use two different kinds of the view of the surfaces. The default view, and you may use solid simple display. It depends on your taste. Maybe this, maybe that, as you like. I prefer to use both types of the view of the surfaces. And let's make the outlet. I will make it closer by using box zoom button. The outlet part. Entities, I must select entities for this part. Click here. Close the selection of points, of the curves and of the bodies. The only allowed select option is the faces. And select the outlet face. By left button. And now I should finish this operation for this part by using a middle point, middle button of the mouse. So after selecting this face, I should click near it or on it the middle button. Thus I created the part which is called outlet. The next part, the wall, the upper wall, we will call it wall. simply. Select this face and again click on the middle button. Very good. Now we have in our tree the paths outlet and wall. If we use the solid view of the paths, it's also very easy to see it. Now let's select the symmetry plate, symmetry surface. We will call it SYM SYM1. Click on the symmetry surface and middle button click. Now we have the SYM1 part. Then the SYM2 part. It is located here. Okay. And middle button. Now we have both symmetric faces. Let's go to the inlet part. For this case I click Fit Window button and again use the box zoom button for the inlet part. I have two inlets, the fuel inlet and air inlet. So fuel inlet, I will write it in one word: inlet. Fuel inlet. In the near the center, near the axis, and air inlet, AIR inlet. Select the face and middle button. So I have got all paths for setting the boundary conditions in the future. I close this window and check the paths. For this case I use a solid view and try to examine this. SYM1, air inlet, fuel inlet, SYM2, wall, and outlet. So that's right, it's okay. Now I will make it visible. Save the project on this study. Then the very important operation for 3D geometries is the creating of the body. It is important for 3D problems, I repeat. Let's close the surfaces visible showing. I hide these faces. And now the operation create body. The name of this part should not be the same as the faces parts. I will call the body flow. The method for selecting the I should create the point which will be inside the flow region. It should not be on the faces. It should be exactly inside the flow region. The standard operation for it is selecting the centroid of 2 points. I will select 2 points, and the center between them should be inside the flow geometry. So select locations. Then I will select, for example, this point. Click on it. And the second point will be here. I think the centroid between these 2 points will be really inside the flow region. I selected 2 points and again click middle button. You see that the point flow appeared. Let's look where it is. From this view it inside the flow geometry. And from this point we see that it's inside our geometry. Okay, the flow body is ready. Then let's use XY coordinates, XY view. And the next very important operation is making the blocks. So let's go to the blocking page. The only active button is create block. Select it. Very important, the part in the upper region of this option should be the name of our body flow. If it is not this name, you should change it to flow. But you see that I have got it by default. The flow is the part on which I will build our blocks. Now we have 3D problem, so the type is 3D bounding box. nothing will be changed. I click OK. And I hope that block is ready. Yes. So we have the geometry of our flow. It has points and curves. And surfaces, of course. And also we built the block, which have subsets, vertices, and edges. The task is to associate the points of our geometry with vertices and the curves of our geometry with edges of the blocks. But at first we will edit our block. We have only one block, we should have more. The first operation is to merge vertices. We have some vertices which will not coincide with points. So let's go to merge vertices operation. Oh, at first we'll go here. Okay. We must connect these two vertices of our block. We have two vertices. We will make one, merge into one. For this operation, use the first merge vertices button. Check out the propagate merge. Clear this checkbox. And select two vertices which we will merge. Select this vertex and this. Okay. You see that in this part we've got one vertex instead of two. And the same we must do in the right part. So fit window. Enlarge this part and again click on the vertex, the first vertex and the second. Very good. Now we have only one line on the near the axis, and this line will be associated with the axis of our geometry. Close the merge vertices window. We may hide the bodies now. I will save the project before the association operation. Save project. Very very strange surfaces. We don't need to see the surfaces. Okay. At first I will make the associations of points and vertices. So select the Associate button. The first button is used to associate vertex. I will enlarge this part. Oh no, sorry, one operation I forgot. 1 minute. I need to split this block into 2 parts, of course. I forgot it. So in blocking window, in blocking page, select split block. Split block operation. Select edge on which will be the splitting. I will use this. And I can move this splitting line. For example, this will be okay, but I can then later improve the operation. So I splitted this line, and again middle button click. Now the block is split into 2 parts, I hope. Yes, it's okay. We have very simple geometry, very simple blocks, but now we must associate the points and vertex. The plan is the following. I will associate this vertex with this point, this vertex with this point, this with this, and these points also should be associated. It seems that they already the same, but if we look very thoroughly, we will see that they not coincide, in fact. So the associations should be set for these points also. So associate point, select vertex, this, I click on it, and then click point to which it should be moved. Then this vertex and this point. Click vertex, click point. Okay. Next, this vertex and this point. And the same here. Click vertex, click point. They seem to be in the same position. The next operation for this part is association of curves and edges of the blocks. I change operation to associate edge to curve. Select edge, for example this, then I should click on the button to make this operation done. Click middle button. The numbers appeared in the edges, so the selections of the edge is ready. And now that I will select the curve of my geometry. Select and also done operation by middle button. So these parts are associated. I can watch this association by the following operations. Click on the edges right button and select show association. This green arrow shows the association between edge and curve of the geometry. The same thing is for this part. Click on the edge, right middle button, the edge is selected, and the curve. Click on the curve and middle button. The association is ready. Let us look at it. Oh no, sorry. Yes, it's ready. Okay. We have finished with I'm not quite sure, sorry. Let me see. Oh yes, I have some problems with association. I have not finished all operations with association of the edges and curves. To improve this situation, I will associate this edge with this curve and so on. So again, association button, select edge, middle button click, and select the curve. Okay, very good. And the same here. Curve, edge, and the curve. And now near the axis I will do the same. Edge, curve. Again, edge, curve. I hope now they are located good. I don't like this. I can't understand why they are not connected. Sorry. Maybe I also should associate the axis line. So again, this button, associate edge to line, to the curve, select this, and then select the okay, why is it so? Oh yes, sorry, everything was okay. It's the mesh lines which are not located on the wrong places. So let's go to the right part, to the outlet part. Again, I have some strange things. At first, association of vertices. So the first, this point, this vertex, this point. Now vertex point, vertex point. Okay, and now let's make the association of the edges. The geometry doesn't have any curves here, so we will associate only this curve, this edge with this curve. Okay, then this edge, it consists of two parts. I select both, and this curve. Okay, now this curve and this edge and this edge. They are very close to each other. Select it, and this curve. Okay. Let me see how it was built. Snap project vertices operation and apply. Oh, okay. I hope that all associations are ready for the building of the mesh. You see that the association operation is very complicated problem. Let's view all the geometry. Close the association window. And begin to build the mesh. For this purpose, we will select mesh page, and then global mesh setup, and the only thing that we will make in the global element seed size, change the maximum element. We remember that the radius of fuel inlet, for example, is about 30 centimeters. So I will make the maximum element about, for example, 2 centimeters. I'll try this number. So 0.02 maximum element. It's the test value. Maybe we'll change it later. Click OK. Then return to blocking page. Use these pre-mesh param buttons. The first button should be selected update sizes and click apply. Now let's check the pre-mesh in the blocking here. By this operation we will build the mesh. So select this. The window asks us, should we recompute the mesh? Of course, we always say yes. Answer yes. The better view of the mesh is a solid option. So right click on the pre-mesh and select solid and wire. Let's look at our mesh. In the end, I think perfect. And in the inlet part, I think it's okay. Now we will make the sizes near the inlet smaller than in the other parts. The inlet part is very important for us. So let's change some sizes of our mesh by the following operation. Clear the pre-mesh box, checkbox. Enlarge the inlet part. And let's change the sizes of our mesh near the inlets. At first, fuel inlet. Select this edge params button. Select the edge near the fuel inlet. We have only 6 nodes here. It's not enough for our problem. Let's make about 15. Even maybe it's maybe we should use even more. No, for the first test solution we may try 15 nodes. The size here is real size is shown here, so it's about 3.5 millimeters, the size of the mesh in this direction, on this edge. Click apply, and let's look at our new built mesh. Click again pre-mesh, answer yes, and now we have much more fine mesh near the fuel inlet. But we have very big difference between the size of fuel inlet and the air inlet near this point. So let's change the air inlet in the following way. Select, make clear the pre checkbox. Select this edge. We have 14 nodes. Let's change it for about 21 edges. And in this case, we must check this box, copy parameters. In this case, we are using method that our numbers which we'll use will be copied to the other parallel edges. You remember that the size of the fuel inlet is about 3.5 centimeters. Let's make the first cell of the air inlet just the same. So the spacing 1 is located in near the point from which these arrows are going. So spacing 1 I will change to 0.3036, 3 millimeters and 6. No, it's I think even 2, of course, 2 zeros. Так, 0.0036. The ratio between the sizes of the mesh is recommended to be about 1.2, maybe less. Click apply, and then again build our mesh, recompute. Now we have the size of the mesh is enlarging very slowly, so the mesh is much better. The same we should do with the axis. So select axis edge, we have about 100 nodes. I think it's okay. And let's change the spacing 1. It should be very close. It should have the value very close to the vertical size. So the spacing 1 I will make, for example, 1 centimeter. The ratio 1.2. Okay. Again apply. The copy parameters must be checked. And rebuild the mesh. Clear, and again click on it. Yes. I think the mesh is ready in this part, but we have not perfect mesh near the outlet. Let's correct the situation. Так, the questions I will answer, sorry, I will answer them in the end, because I will answer in Russian. So, 1 minute. Let's go to the right, the outlet part. In order to answer your question, my English is not enough for this answer. Let's improve the situation with this edge. So select this edge. And I think that it should have the same spacing everywhere. I clear the copy parameters. Then change the spacing 1 to 0 and ratio 1 to 0 also. It's the resetting of the values. when we use the 0 value. Click apply. And the same I have to do with the with this edge. Also 0 spacing 1, and ratio also 0 apply. Now I hope that there will be no all sizes of these edges will be the same in the vertical direction. Clear premesh. Check it. Yes. Well, now I think it's good. Maybe we may improve this mesh, but I think it will be okay for our next calculations. Close the window of the edges params, and make the last operations. Right click premesh, and we must convert it to the unstructured mesh. CFX and Fluent are using unstructured mesh. We have built the structured mesh, so now we have to convert it to unstruct option. Click on it. They say that mesh is already exists, but we must replace it because the mesh which was built by default is of course not useful. Replace. Now we have the unstructured mesh. Let us watch it in solid and wire option. It looks just like the structured mesh, but in reality it has the configuration of unstructured mesh. And then let's output our mesh for the solver. Select output mesh. Select solver. We see by default it's Fluent Mesh. Let's try to use the Fluent Mesh format is very useful for all calculation. We may use other solvers, but the Fluent Mesh file will be good for this calculation. So at first let's try to build Fluent Mesh. Apply, click apply. Then make sure that all paths for the boundaries conditions are ready. Select surfaces, one-sided, and we see that air inlet, fuel inlet, outlet, SIM1, SIM2 and wall are here. It's okay. So accept this situation. And let's output our mesh. Now we have 3D grid dimension. So use 3D, not 2D. And we will also use not binary file, but text file. So I select no for write binary file. And done. No red lines, no red colored text. Okay. Let me look at this file. I have it. In my working directory. Chamber 1 files, dp0, ICEM, ICEM CFD, and my mesh, the file with extension MSH. Let me look its text file so I can open it by viewer. I am interested in the end part of the file. So I have the fluid, the int fluid, and all boundaries: outlet, wall, sim1, sim2, fuel, and inlet. And here we see the coordinates of all parts which are needed. We are using 16 system for these coordinates. Close it. Oh no, I will copy this file for my reserve. No. Now I have the copy of this file. Yes, okay. And now let's try to use not Fluent but CFX file format. It's optional operation, but let's do it. We have the format ANSYS CFX. So let's use it, apply. Now we will have another interface for CFX file. Coordinate system global. The file will be in ASCII format. But now I can use even a binary file if we don't have problem. But let it be text file. The file will be called ICEM CFX5. Done. I will open the file. Yes, I have this file. ICEM CFX5. Let me look at it. It has another format. I think we have only decimal coordinates. I can also produce the binary file. but I will call it in the other way, ICM B CFX5. Done. Now I have the file ICMB. It has binary format. It's a little bit better because the CFX file is much bigger than the binary file. For this lesson, it's enough. I think we must stop the lesson for this case. And now I will answer your question, try to answer. I will close, stop the English lesson.